There's more than one way to join your parts. In this lesson, we're going to talk about how to add tapping to your designs. So let's get into it. For our next lesson on hole operations, we're going to talk about tapping. Now, what is tapping? Essentially, it's the cutting or forming of internal threads on a hole that's going through our part. Now, on thicker parts, this could be what's called a blind hole, so it doesn't go all the way through, or it can be a through hole. In this lesson, we're going to focus on through holes since we're talking about sheet metal. Now, how is that actually done? Well, there's multiple different cutting operations or forming operations depending on the tap that you're going to use, but the first thing we need is have a hole that goes through our part. This is done on the laser side of the process, and then the tapping is done on a secondary operation. Now, the tap is going to be on a forming process, is actually pulling and forming the threads into the shape that you want. This is considered a stronger form of threads that we're going to be putting into the part versus cutting, in which we have a hole that's cut through, and then we end up cutting with a hardened bit, essentially, the threads into the helical pattern that creates the screw type threads that we're looking for. Now, there's a handful of different nomenclatures that we need to know when we're picking out the right threads for our design. It depends on whether you're working in imperial or in metric, right? So if we're looking at imperial, there's UNC, which is Unified National Coarse, and UNF, which is Unified National Fine. Now, this is kind of a mouthful, but what it really means is that it's the size of our thread, or the outside diameter of our thread, and the threads per inch. So let's focus on this first one. If we have our example of a 1/4 inch, then our outside threads here are going to be a 1/4 of an inch. So on this one right here, 1/4 of an inch in our diameter. Now the 20 is a little bit more complex, and this is going to work for both of our imperial threads, is threads per inch. And it's exactly what it sounds like. We're going to measure out 1 inch of threaded area, and we're going to count how many threads are in that 1 inch. So on a 1/4 20, that means that there is 20 peaks within the 1 inch area, and on our fine thread, it's going to have 28 peaks. So you can I get an idea that a coarse thread is going to have less peaks per inch, and a fine thread is going to have more. There's 2 different times and places to use these. Fine threads typically end up having more threads, so if you have thinner material, you can get a little bit more thread engagement, but they are prone to galling since there is more surface area in contact. So just kind of know the difference between these two. When you see 1/4 20, you understand what you're picking out. Now metric is just metric. There's no fine or coarse, but what they end up doing is having a similar idea on the back side of it. M5 is going to be the diameter, and then 0.8 is a different type of measurement. So on that, it's going to be the measurement from peak to peak. So on this example right here, we have M5, which is our diameter, and 0.8 is 0.8 millimeters from peak to peak. So the bigger this number, if this was 1.5, would be a coarser thread. It's more distance between the 2 peaks versus 0.8, which is less distance. So now that we understand that this peak to peak for metric, threads per inch for imperial, we know how to pick out our threads. Now, the next thing that you need to know is thread engagement. Now, this is going to be dictated by the hole size in which you cut through the original part. The larger the hole, the less thread engagement. And what I'm talking about here is how much our threads are contacting each other. And so I end up having this little diagram here. If my threads essentially are, if my hole is larger, I'm going to have less thread engagement. So hold that up over my face. But this contact area that we have in here is what we're talking about. If I drill out the internal hole on the original hole larger, you can see here that I would open up this hole and I would have less area in which the 2 pieces are touching each other. What we're typically looking for on a good thread is 70% of the available surface area is engaged with each other. And so when you kind of see thread engagement, that's what you're looking for. That's what it's talking about in the background. Now, the cool thing about this is that just like all of the other hole operations, every hole is going to be resized for you. So you don't need to necessarily know what hole size or drill size, what we would call that you need to have for the particular tap size that you're looking for. You're going to select, say, 1/4-20. It's going to change it to the hole size that SendCutSend needs in order to laser cut it and then tap it for you, and you're good to go. Now, with that being said, this allows us to put hardware and screws into parts that we don't necessarily have. But there's one big thing that we have there is a minimum material thickness. As we thin up this material, there's going to be less and less threads available in that material. So if we have 1/2 inch thick, we're going to have plenty of threads in it. If we drop down to, say, 40 thousandths thick, we're not even going to have a full thread engagement in there, and that doesn't allow us to have those threads. So when you're checking out, if you drop underneath a certain material thickness, you're going to end up losing the availability to have tap sizes available for choosing. So that's kind of where we're at. Now, the rule of thumb is to have 1 to 1.5 times the bolt diameter to depth or thickness of material. Now, this is a rule of thumb. It's going to tweak a little bit depending on the material that you're picking out and also just the fact that we're cutting it through sheet metal. So that's just a general rule of thumb. When that becomes too thin, I want you guys to go check out our next lesson, which is hardware installation, but we'll stay in this one right now. Now, once we understand that and how we're kind of cutting out the threads and the nomenclature of which we need to pick out, what we need to expect is we're going to see oil or residue potentially on the parts. This is done through the cutting process or that secondary process that they need to go through. You might see a slight burr. If you don't choose the SendCutSend deburring process, you might have to do a little bit of deburring, and we only offer right-handed threads. Now, with all of that in mind, let's jump into CAD here and show how to actually check out a part with tapped holes. Well, we have that 5x5 rectangle here again. I'm going to go ahead and create a sketch. And in this one, we're going to just put a circle in the corner here. Let's throw 2 dimensions on it really quickly. Let's say 1 inch by 1 inch. And with this, we're going to end up just having any hole size here. This is just a placement. Now that we have that, we're going to go back up to our solid. We're going to go to hole again in our create area. This is the same thing that we used to do countersinking, but now we can select a couple different options. Here we can go back to simple hole, and in hole type, we're going to move over to tapped. Once we're in there, we're going to get a new dialog box that drops down below that. The first thing we're going to see is that we have the size of the threads. If we drop down into, say, a number 10, then it's going to give us designations for a 1024. We can also change to have metric threads and different unified threads here as well. If we increase this back up to, and we can also see our thread pitches and our designation as well. So we can change this, say, to a 1032, and we'll actually increase this a little bit so we can see what we're doing here. So we'll back to 1/4 inch, and we'll change this to, say, 1/4-20. Coming in here, we're going to zoom in and rotate the part up a little bit. You can see essentially a picture is drawn on the inside of the hole. And that's because we are actually not modeling these threads, even though we do have the option here. So underneath the dialog box, we can check modeled. We can see those threads actually physically get put into the part. Whenever you're wanting to do a manufacturing process, whether it's laser cutting or even CNC, it's highly recommended you don't actually have them modeled. Just use essentially the picture on the inside of the part to designate that. Now what this is doing is it's automatically turning it into the hole size that we want for our 1/4-28 thread. Now that we have that, we can click OK. And you can see here, I still have a selectable hole in here, and we're ready to create a sketch. Now that we have that sketch on the surface, we can go ahead and create that DXF and import it into SendCutSend. Now that we're all the way into the process of collecting a hole selection, we're going to go into hole operations, we're going to select tapping, and we're going to select that 1/4-28. Again, what we're going to see here is that we can change the hole size here, and it's going to resize the tap. So if you changed your mind at this point and you want 1/4-20, you can select that thread instead. It's going to resize it for you. Once you have the proper tap size selected, go ahead and check out. Well, from here we can see that Tapping is a great way to add threads and hole engagement so that we can have two parts mated together with a bolt or other process. Now, a different way that we can do this is hardware installation, and that's what we're going to get into in the next lesson. So we'll see you there.